Okay, everybody.
I wish that was true.
What we're going to do today is we are going to spend time preparing for this test. Forces are one of the larger portions of the exam, and it's not that bad. Students tend to make forces harder than they really need to be. Well, we talked about the systematic way of going through and making sure you do a good job on them, all right? So let's start with forces. Everybody got your packet? First thing I want you to do is, where do we want to start on this one? Let's do this. Why don't we solve? Okay, everybody, we got the very first page. This is the very first page. I want you, with the people around you, to work this first page. All the multiple choice on it. Okay? And while you're doing that, I'm going to post the key outside on the wall so you can take a look at it. So let's do our multiple choice. Check your answers with the people around you. Make sure you get the same answers as them. All right, there are 2, 4, 6, 8, 9 problems. All right? So 9 problems. It shouldn't take you any more than about 10, 15 minutes at the most. Where's your review packet? Yeah, eliminate the ones you can't. All right, we had a really great question. The question was, if we can't figure one out, should we guess? And the answer is yes, you should get in the practice of guessing. Now, when I say guessing, I mean you should eliminate the ones you know can't be right, and then pick the best one you can from the rest. Okay? Okay, let's start with this one right here. Number 1. And the answer is?
D.
You guys got a frictional force.
D. Okay, here's the deal.
Yeah, if they hit the brakes, then also.
Okay, the object of weight W is suspended. Okay, the angles from the 2 wires are the same. Okay, so here's the deal. There is a force this way, W. There's a force this way and a force this way. Both of them I'm going to call tension. All right? It's in equilibrium, so it's not moving. Therefore, the acceleration is 0 and the forces all cancel. So is there any reason to pick any other coordinate system than X and Y? Okay, X and Y is going to be the easiest, so let's pick that. And when I do, this one splits into X and Y, and these are X. So these two have to cancel, and the 2 ups have to equal the down. And since it's symmetrical, you can say that W down must equal, there's 2 T cosine theta, because this is the theta right here. So that yellow component is the cosine theta part of the tension. And since the angles are the same, the 2 tensions will be the same. Okay? So you end up with tension equals W over 2 cosine theta. Now remember, most of you picked B. Remember, you're not finding the component of the weight. You're finding the component of the ones that don't match up with your coordinate system, right? So since our coordinate system is up, down, right, and left, then we're just picking, this one's already in the Y direction, so we don't have to find its component. Okay? All right. Number 2. The deal is that this has mass and this has mass. So this part of the rope has to hold both of the masses up. But this part of the rope right here only has to hold up the bottom one. So the answer is E. The weight or the tension in the rope varies from top to bottom. And we talked about that in class, I thought, didn't we?
Yeah, the train.
Yeah, with the train, it's the same kind of problem. Okay? And we also talked about like oil wells, right? I think we talked about that too.
Yeah.
Let's jump over to number 6. Okay, number 6, what's the answer?
I didn't get a chance to do it.
Oh, the answer is A. Oh, no. You're welcome. All right, now on this one, a person travels to a new planet. Okay, you got to find out the new acceleration due to gravity. So remember, mg on the planet equals big G, mm over r squared, where this is one of these m's leaving behind the mass of the planet, and this is the radius of the planet, right? So G equals big G, big M over big R squared. Mass of the planet, radius of the planet squared. Okay, so what are we doing to our planet? We are double the mass and double the radius. So double the mass and double the radius, but the radius is squared. So that ends up being 2 over 4, big G, big M over R squared, where this is equal to 9.8 for Earth, right? So it's 1/2 of that. So if we're 1/2 of the acceleration due to gravity that we have on Earth, then it's going to be half the force, so we got half the person's weight. All right? Okay, how about number 7? Work done on the block by the gravitational force during the 5 meters it slides down the incline. Okay? So how do we figure out work? You could do F delta R cosine theta. You could do it that way. Or, what does work also equal? The change in energy. Okay? In most cases, the change in energy is easier of the two to do if you can figure out what kind of energy is changing. Okay, what kind of energy are we changing? Yeah, we're changing, the potential energy is going to be changing, right? It's going to change from potential to kinetic. And so that's going to be M, it's going to be a change in gravitational potential, which is mgh, right? And that's the delta H. So that's 3. And you know the mg is already 20. Okay, so 20 times 3, which gives us a grand total of 60. Okay? All right, how are we doing so far? Just one so far? All right, 1, 2, 3, 4. I missed one. Okay, if you keep that rate up, that's fabulous. All right, number 3. Number 3, object of weight W on the surface of a planet, blah, blah, blah. What is the gravitational force on the object after it has been moved a distance 4r away? So you've got object sitting on the planet, and then you move it from R all the way out to 4r. And what happens to the gravitational force? First of all, which ones can we eliminate?
The ones that increase.
Gravity force goes down. So it's got to be one of those two, right? So you got a 50-50 shot, right? Yeah, but it is easy. Force of gravity equals big G m1 m2 over r squared. And since I've quadrupled it squared, that's going to give me 1/16 of what it was before, right? All right, number 4, a person weighing 490 newtons is standing on a bathroom scale in an elevator, is accelerating up at a rate of 0.2 meters per second. What does bathroom scale indicate the person's weight is? All right, so person. Okay, bathroom scale force up, which is otherwise known as the normal force, and you've got mg down, right? And you're accelerating up. So my acceleration is up this way at 0.2. Okay? Meters per second squared. All right, so what do?
Make an educated guess.
Well, okay, tell me. That's a good place to start, actually. Where will the bathroom scale read the person's weight? It's going to have to be higher, right? So we know it can't be this person's weight or lower, right?
Or E.
Or E. So you got a 50-50 shot again, which is greatness, right?
Yeah.
So we just got to figure out which one it is. And you probably can make a pretty good guess. If you're only going up at 0.2 meters per second squared and gravity is 10 meters per second squared for acceleration due to gravity, which one do you think is a better guess?
D.
Probably D. You're probably only going to go up a little bit, right? And here's how you solve it. F equals ma, you're accelerating up, so our forces up will be positive. So I've got normal, which is what the bathroom scale reads, minus mg equals ma, but my acceleration is 0.2, right? But, whoa, 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 what's the mass of the person?
490 divided by 10.
Yeah, it's not 490, it's 490 newtons divided by 9.8. I think this is one of these I didn't put on the exam, because if you don't use 9.8, you're going to be off by a little bit. So this ends up being 50 newtons, 50 kilograms. So you got to put 50 in here times 0.2, and then right here is the 490, and then you got n, and 50 times 0.2 is 10. All right, so that's how you get to that answer, which we would have probably guessed anyway.
Can we just common
nice
common
educated
sense? I mean, you're only moving 0.2 meters per second, so it's not
Right.
a lot.
You know what? Yes, you could if you're attacking this problem with the idea of everybody. If you're looking at these problems with the idea of I'm picking the best answer available, instead of trying to find the correct answer, find the best answer available. We know these can't be right, and what's left, that looks like the best. You can do that. You certainly can. All right. Braking force is applied to a car moving at 30 meters per second. The car is brought to a stop in 15 seconds. What's the force? Okay. Now, is there any here that we can easily eliminate this time?
Yes.
10 and 1200. I mean 10 and 12,000.
Why?
Because they're too long.
How do you know?
Because they're too long.
But how do you know?
They're illogical.
I mean, you can't do it right away.
Why?
Yeah, you can't do it.
You can't do it right
can't
away.
say-
There's no logical way right off the bat for you to immediately eliminate any of these, right?
Okay.
It's not
So-
amazing.
We've got to do, we're looking for a force. So F equals ma. The problem is you don't have acceleration, or do we?
Yeah,
We got the
we do.
velocity
Per second.
And the seconds.
and the time it takes to stop. So acceleration, at least average acceleration, is the change in velocity or the change in time. So we got 30 divided by 15. So we get, technically it's -2, but they're only wanting to know the magnitude, right? Because they're all positive. So we're going to be okay making it positive. So we've got a mass of 2500, and we've got an acceleration of 2, so we get 5,000. Okay? All right, and then that takes us over to this one. That's a kinematics problem. Let me just show you how that one works. It's just x equals x naught plus v naught t plus 1/2 8t squared. And you know it starts from 0 position and 0 velocity. And you're given enough to find the acceleration, and it's 6. Okay? And then our last one. The sum of the forces on the object are 0 in which case? It seems somewhat arbitrary, but how can we tell well, how do we know if the forces add up to 0?
Set equilibrium.
Ah,
Velocity.
that means acceleration is 0,
Velocity.
which means the acceleration versus time graph looks like that, which means the velocity versus time graph has to look like
Straight line.
some sort of,
Horizontal.
yeah, some sort of horizontal line, either there or there, right? So displacement versus time has got to be something not curved, right?
Yeah.
Okay, so this one won't work because that's accelerating because the velocity is changing with the slope. Constant velocity, so it's got to be c, right? There you go. All right, that wasn't so painful. Yes, you may. Everybody, problem number 13 on the third page, I guess. If you will note that there is a diagram missing. Somehow or another I missed the diagram. It's right here. Okay, so add that diagram to problem number 13, multiple choice. All right? Okay, while you're doing that, let me remind you the test is next time. The test is somewhat short. It's only 60 minutes this time. It's only 3 free responses, 16 multiple choice, okay? Okay, one thing that will be on the test that I want to remind you of is static electric stuff will be on the test, so why don't we go to the second to last free response and make sure we know how to do that one. We're making sure we do static electric stuff because that gets us prepared for when we do electricity, okay? So the second to last problem in the free response section, all right? Problem number 103, I believe. All right, let me show that one up here. Actually, let me erase this. Okay, it says you've got 3 particles that are fixed in a horizontal plane as shown above. Particle 3 at the top of the triangle has a charge that's given, +1 microcoulomb, and has an electrostatic force F due to the other charges. It's entirely in the negative x direction, as shown. The magnitude of charge 1 is known as 4 microcoulombs, and the magnitude of charge 2 is known to be 1.7 microcoulombs, but their signs are not known. Okay. Determine the signs of the charges, Q1 and Q2, and indicate the correct signs below. So will you do that for me? Don't tell me. Figure it out, and then explain it to your neighbor. Make sure your neighbor has the exact same reasoning. Okay, which ones? All right, so here you go. You got it? Yep, no? Sure, yep. Q1, what is it? Negative. Q2 is?
Positive.
How do you know?
Just going that way.
Because if we make that this charge, it can either attract or repel. And this charge here can either attract or repel. Okay? So the only pair of forces that give you any shot of getting in the right quadrant or to the left is this one and this one. So it has to repel. So if that's positive, that one has to be positive to repel. And this one's got to attract to give you a force in this direction. And so this one's got to be positive and it's got to be negative. So there you go. All right? So we have that going for us. That was pretty straightforward. On the exam, just so you know, a lot of the exam questions nowadays are moving towards this kind of question, where you kind of check a blank, and a lot of times they'll ask you to justify your answer. Okay? This one did not.
Amen.
Yeah. On the diagram, draw and label arrows that indicate F1 and F2. Well, I just did that for you, right? So on this diagram down here, you were supposed to draw these 2 forces, and that's what they look like, right? Up and away into the second quadrant, and then down to the left, the yellow one, into the third quadrant, all right? So we just answered the first couple. And I guarantee you that's where the point, and that's where the point, and down here, giving that force and this force right here, probably a couple more points. So I think this is looks like a pretty short problem. So this one's probably worth 10 points, and you already have 4 of the 10, which is really nice. Because remember, we're shooting for half the points or better. Okay? Because sometimes we won't get that, but if we shoot for half or better, then we are guaranteed passing the exam. And probably getting 4 if we can actually get half or better on all of them. All right, so part C, calculate the magnitude of F. All right, so there comes the fun part. Calculate the magnitude of F. Oops, one too high. All right, let's do that one then. We're going to figure out what that force F is. Rudy.
Take my answer because you already went over that. I was like, making sure.
All right. All right, so everybody find F. How are we going to find that? Yeah, this is going to require, this is probably the harder part of the problem, right? So we're going to have to find,
Or X and Y.
we're going to have to find those two forces, okay? You have to find that force, and you're going to have to find that force, and you're going to have to add them up. But the one nice thing is that do we have to worry about y components?
No, they cancel.
How do we know they cancel?
It's a horizontal force.
It says it's horizontal. So all we have to do is find the x component of this one, right? And we've got to find the y component of this one. I'm sorry, x component of that one too. And add up their two x components to get our grand total. Okay? And do we have nice, easy angles? We do. We have a 3, 4, 5 triangle. All right. So let's see you rifle through that map. Rifle through.
Yeah. The forces of the particle motion.
Right? Okay, this is going to be, end up with a plus or minus force, but remember,
We use that.
yeah, we want to take the absolute value of this, remember, because we already know the directions. We've found our directions, correct? So we don't worry about the plus and minus, because the plus and minus just means attract or repel, and we've already taken that into account. So we know that our two components are going to add up. Yes, sir. Okay, there's got to be at least 20, 30 keystrokes justifying each force, right? So make sure that you spend time to make sure you get it right. It's easy to get these wrong. I'll come back and check it when you're ready.
I got it. That commercial trips me out.
This equation is the bane of students' existence. This one and the gravity equation. Actually, this one, because it has plus or minus, is a little worse.
Yeah.
With Jojo Army?
And,
Okay, we've got,
Yeah, for a rookie.
okay, this is the force from number 1, okay, from charge number 1. K is 9E9, and by the way, don't forget, K could be written 1 over 4 pi epsilon naught, right? But it's the same number. 9E9, Newton meters squared per Coulomb squared, right? I'm just going to write the number. Okay, charge number 1 is, where am I? Charge number 1 is 4e to the negative 6 coulombs. Charge number 2, I guess this should be charge 1 and 3. So charge number 3 is 1e to the negative 6 coulombs, all divided by the radius in between, and the radius in between, they were nice to us, it's 4 meters. But it's squared, so don't forget to square it. Okay? Alright, what'd you get for this?
Total?
Yeah, just for this one.
0.00225.
0.00225 newtons, or 2.25 e to the negative 3rd newtons. Okay? Everybody make sure you can get that. Because if you can't get the, if you can't get the K calculator to give you that answer, then we got to figure out what's going on there first. Yes? For a Wookiee. All right, and that one is down in that direction.
This tulip is huge.
So save you problems. This part right here. Okay, and we just want to find the x component.
Oh, it's 2.25.
That's this one right here. 2.25 e to the negative third newtons. We will find the x component. That's this part of it. So we need an angle and we need a sine or a cosine. Give me an angle and a sine or a cosine to give us this one.
And
37 with a
2.5 cosine.
Yeah, I think most students will pick that 37. So it's going to be that, what we want right there is 2.25 e to the negative third newtons times the cosine of 37 degrees. And then that turns out to be 1.8 e to the negative third newtons. So that is this one. And then we got to repeat this whole thing for the other one. There's like, what, 3-4 million keystrokes on this one problem right here, right?
4 million, that's perfect.
Okay, how do we maximize our points on this? What do we have to show that most of you aren't showing to get maximum points?
Basic equations and solver.
It's important that we show the base equation that we are going to use. Show the equation. And then, what's another key component?
Solve for whatever you solve first.
Well, you could solve for these. They may or may not give you credit for these parts. But what they will certainly give you credit for is showing that you need the x components. How do you show that?
Draw the components.
You could draw the components. You could say that I am trying to find the x component of this one, right? You need to show, or just make a statement. X components add up. Y components cancel. Or something that lets them know that you're only looking for the x components, all right? Okay, this pink one right here is going to be F equals K Q2 Q3 over R squared. So that's 9E9. Q2 is 1.7 e to the negative 6th coulombs. Q3 is 1 e to the negative 6th coulombs over the radius squared, which is 3 meters squared. When you work that out, you get 1.7 e to the negative third newtons. All right, if you are unable to get this, you need to keep working until you can get it. Because this is a calculator issue. It's not that hard.
Wait, that's the final answer?
No. That's the pink force. I don't want the pink force. What I want is the red component. I want this component. I don't know if you can tell that that's red or not. But this is the force from charge 3 on charge 2 on charge 3. So I want the x component only, which is going to be 1.7 e to the negative third newtons. And that angle right there is going to be 53, right? Same angle. So I have a cosine of 53 degrees. So that gives me 1 e to the negative third newtons. Now what do I do? I add those two together. And when I add those two together, I get the final resultant force, this whole big force right there, to be 2.8 e to the negative third newtons. Okay, on this one, if you don't show your work, you're going to get little to no points for all your effort. So you need to show the original equation. You need to show at least your original substitution, because they may give you points for that. You need to show that you want only the x component and that you're going to add the two x components together. This is going to take up a lot of space. You need to show it piece by piece by piece so that a grader can read it. All right? That was probably worth 4 points. A lot harder to get those 4 points than the original 4 points. Yeah.
Why don't you just rotate the triangle?
You rotate this triangle.
Yeah, my plane. I just rotated the plane. Like the
X
coordinate
plane.
plane?
Yes.
And it's way easier.
Now, when you do that, you still find this same force, and you still have to find this same component, though, right?
Then you just use Pythagorean, yeah, which is easier.
Or you did that one plus that one Pythagorizes to give you that?
Yeah, I know.
That one, no, that one gives it that.
Oh, you know what? Actually, that is a shortcut that will work fabulously.
Oh, I think that they were not.
And here's how that works. Is that because this angle right here is 90, you could do this. This one and this one. This is the same as this one, right?
Yeah.
And then all you had to do is take this one squared plus this one squared equals what you want squared. That would work. That's correct.
I want, give me
That
what
will
I want.
work. I didn't even think about that, but that will work because we have a right angle. Now, if these two weren't at right angles,
Give me what I want.
yeah.
But they're always going to give us right triangles according to you.
Well, I will say that you should always on the exam look for right triangles and look for those special 3 triangles, 30, 60, 90, 45, 45, 90, and 3, 4, 5, right? Because they show up more times than not. Not always, but more times than not. Because what that allows them to do, that allows them to ask harder questions and more questions. Because the math's a little bit simpler, but they get to ask you more physics type questions. And you don't have as much math to deal with. That's correct.
Don't worry, this is
Okay, down here.
Oh, Marcos.
Last one. It says, where could you place a positively charged particle so that you could make the force on charge 3 0? Put an X in the box and justify your answer. Oh, there it is. So put an X in the box and justify your answer. All right. Which box?
A box.
The one
What are you
between
pointing
The
at?
one.
Yeah, wait,
wait,
no,
no,
1, 2, 3,
5.
Right.
X. Right there.
It wasn't 5, there's no 5.
That's right. It wasn't 5. It was the X box. That was really bad. All right. Now, how do you justify your answer?
Because the 2 charges get rid of vertical components, one you need one to cancel out the horizontal.
Okay. Since the force here is to the left
And it's horizontal, you don't need
and
any
it's
vertical.
horizontal,
You want no vertical.
you want a positive charge here. Or I should put a plus probably. A plus charge here and a plus charge here will repel, giving you a force to the right, which will cancel that one out. Or could at least cancel it out, right? Depending on how close you place it.
And then what
Yeah,
charge?
'cause like charges repel, and you need a force to the right. So you could say, they're both positive, they will repel, so I need to repel it to the right to cancel out the force to the left. Something like that would work as well. Okay? All right.
I squared it would repel the force more through that.
Repel a force, but it's not repelling a force. It's not repelling the force. What does a charged particle repel? Another charged particle. So it would
it creates a force.
yes, it would create a force that would repel to the right. Okay? So be careful of that. We got students all the time talking about the force of the velocity or things like that. It's like, no. There's no force
of velocity.
All right, let's go to the problem one before the one we just did. About the spring. You hate springs. Well, springs love you. All right.
Every time I try to do one, it throws me away. Every time I hug a spring, it throws me away.
Okay, right here.
It forces you away.
Okay, a block A of mass 2 kilograms and a block B of 8 kilograms are connected as shown with a spring of spring constant 80 newtons per meter and negligible mass. You don't have to worry about the mass of the spring. The system is being pulled to the right across a frictionless surface, horizontal by the way, with a horizontal force of 4 newtons, with both blocks experiencing equal constant acceleration. Okay, so both the blocks have the same exact acceleration. All right, calculate the force that the spring exerts on the 2 kilogram block. All right, so we're looking for a force. So tell me, these are the things we have at our disposal so far. We've talked about kinematics. Actually, we began the year with energy and work. We covered thermo, but obviously this is not a thermal problem. So, obviously not a thermal problem. So work and energy, kinematics, we covered momentum, and we covered forces. Okay? Which looks like your best bet to figure out the force of the spring on the 2 kilogram block? Probably forces, because it's asking for a force, right? Although forces do show up in work and momentum, probably a force problem. So every time we have a force problem, what do?
Elastic.
X, Y.
What's the very first thing we do?
What is it?
Oh,
You do your force.
Break up the component.
Free
Man,
body
you-
diagram. Free body
have I wasted my time yet?
Everybody there.
I answered
Free
the
body
question.
diagram.
I answered the question. I answered the question.
Every time, the very first thing we do is a free body diagram. So, which free body diagram?
You mean
Because
like
there's two of
which
them. There's two masses, two
Yeah. What free body diagram do we draw? Because there are two things here.
Do both.
You separate them.
Okay? If we do this one right here, how many forces?
Well, yeah, one.
Yeah,
I got
Three.
three.
Okay,
I got three.
yeah.
Down, up, and to the left.
To the left?
Right.
Oh, yeah, right.
Oh yeah, your other left. And what we call that force?
It's terrible. When my
Straight
sister
forward.
drives and I'm giving her directions, she has to do the left. You let go of the steering wheel. What are you doing?
What? You just hold the wheel and
Yeah,
tell
that's
it.
what I do.
I'll be like, turn left. And she'll be like, this thing.
She keeps going, one's a 7 and the other one, I don't know what that is.
No, she'll just let go of the steering wheel. I'll be like,
Yeah, the seven. Turn to the seven.
Oh, she
Turn to
let
your
go.
seven.
Just remember,
And then-
7 equals left, right?
This is just-
MG normal and four.
What?
Can I go back?
Yes.
yeah.
All right, are any of these the same?
Excellent.
Yeah,
Instead of
normally.
twisting it around, she takes it off and flips it over.
Spring force is the only thing that's the same.
The MG.
Hey, come on everybody.
Normal and the weight.
I'm trying to get you ready for the test. Work with me.
I'm working.
These two are the same. Any others?
No.
Normal and weight.
That one and that one.
And then the other normal is 15.
And then the other normal and its weight. All right, so we got a whole bunch that are the same. All right, so which force are we looking for?
Spring.
Spring force. Okay, so what should I do? Which, after free body diagram, what do we do? What's our next question?
Component, your coordinate system.
Acceleration. Is it accelerating?
Yeah. Yeah.
Which way?
To the right.
To the right. So now set up your coordinate system. Is everybody okay with setting up this coordinate system?
Yeah.
Yes.
Okay. So now we set up F equals ma. For which one?
X.
That one or that one?
The other one. The one on the right.
Both.
The one on the force, right?
The one on the right?
Yeah. Well, you're gonna need both. Force. You're gonna need both.
Okay, if we set up this one, we get F
And then you want-
equals MA. So tell me, what does it look like? Build it for me.
Okay, so
That's it. Well, F sub S.
Well, N plus
F sub S equals,
M, 2
M8.
kilograms A
This is
equals
your-
2A.
force, right?
right?
Uh-huh.
Okay, if I build this one, well, hey, does this help me?
Yeah, it's,
Acceleration.
not
I'm
alone.
looking for that.
Not
Yeah, the
alone,
force
but it
is
will
equal
help.
to that.
Okay, I don't know what A is, right?
Because M is
So while this
2
is
kilograms.
not wrong, it just doesn't give me the answer. Not yet.
The mass is 2 kilograms.
The mass is 2. Okay, F equals MA. What goes here?
4 newtons minus F sub S equal MA 8A.
and the N cancel out, right? That's what we do.
Okay, once again, I cannot find the spring force because I don't know what A is.
You need to plug it
You
in.
can set the
But I could take that and plug it in over here, and if I do so, I get 4.
Minus 2.
Minus 2A equals 8A,
4
or
equals
4
10A.
equals 10A, or A equals 0.4, right?
Yes.
Meters per second squared, voila.
Why is that right?
Now, thank you. There was another way you could have worked this as well. You could have drawn the free body diagram like this.
You still have to calculate the answer.
Yeah, this is 2 and 8, and there's a 4 newtons this way. If you set this one up, and there's an mg down, and a normal force up here, and an mg down here, and a normal force up here, but they don't do anything in the problem, right? You got this one, and you got this
What are you
one.
talking about? They do a lot of that problem. They keep it
Well, they keep it from falling, that's
and
true.
keep it from levitating.
Okay, look what this one does. The reason I can draw these as one unit is because they both have exactly the same acceleration. If they don't have the same acceleration, I cannot draw them as one unit because part of it will be moving different than the other part. Does that make sense?
Yeah.
Okay. All right, so right here I get 4 to the right equals
10
10A. So A equals 0.4
meters per second.
meters per second squared, which takes me exactly to where I am here. But wait a minute, I still don't have the answer, do I?
No, now you plug it in software and you just
We're looking for the force. So one way or another, I'm going to probably have to find A and then substitute in. Some of you may have thought ahead and said, look, I don't want to substitute F in. I want to substitute A in because I solve for F directly. You can do that if you want. But either way, you take this and plug it in, and you get a force of
0.8
8?
0.8.
No, 0.8. 0.8 newtons.
We need heat.
There you go. Now it asks for what's the extension of the spring. How do we get that?
F sub S equals K.
Yeah, because we know that for a spring it's negative kx. So our force is 0.8 newtons equals, do we know what k is?
No.
Oh, it's 80
Oh,
newtons per meter. And x is what we solve. Now if I solve it this way, notice I'm going to get a negative number.
a negative distance.
Yeah, what really is happening is the spring is pulling opposite to the way it's being stretched. So technically that's negative. Okay, so the negative's going to go away. Because the spring is stretching one way, but it's being pulled the other way. Or applying a force the other way. Okay, I should say. All right, so what's x then?
0.1. 0.01.
0.01.
Meter.
So 10 centimeters. Okay? All right. That wasn't too bad, but it did require you to build a couple of free body diagrams
And think of it.
and think a little bit, get simultaneous equations, and work it out. Okay? Not too bad. Now, this next question is a really cool question, actually. It really makes you think a little bit. Or the next couple of questions. All right, C. It says the system is now pulled to the left as shown below, with both blocks again experiencing equal constant acceleration. Part C says, is the magnitude of the acceleration greater or less than or the same? Don't answer. Part B is, or D is the amount that the spring stretches the same or less, or greater or less than the same as before? So I want you to answer C and D and justify your answer. Okay? Don't yell out your answer. I want everybody to think about it. Is the acceleration greater than, less than, or the same? Raise your hand if you think it's greater than. 0. How many think it's less? 1,
No way.
2, 2. How many think it's the same? Okay, the rest of you.
That's a lie.
Lots.
Lots the same?
Lots think it's the same. Lots of you think it's the same. Why do you believe it's the same?
I worked it
Because I
out.
calculated, yeah.
Okay, because you worked it out and just solved it. Okay,
figure out it was the
and then
same.
you can justify your answer by showing the math that shows it's the same. That's one way to justify it. What's another way you can justify it? Yeah,
Because the blocks, they're all 1 unit, so it's going to be...
because you could say, look, F equals MA. The mass doesn't change. They're all moving together again.
Still the same.
And you have the same force, so you must have the same acceleration. Okay, that's another great way to explain it.
Because it makes
That's probably
sense.
the more.
Now, what about this one? Is the amount of the spring stretch greater than, less than the same? How many say the stretch is greater? Raise your hand if you think greater. 1, 2, 3, 4, 5, 6, 7. How many think it's less? None. How many think it's the same? Whoa, no, nobody. So we only have 7 out of 26 answers.
Wait,
You must answer.
one more minute.
Okay, I'll give you another minute. You must answer.
Yeah.
All right, once again, you can answer this one with math
Greater.
or with... Okay, how many say greater now? Raise your hand if you say greater.
I'm thinking logically.
Okay, let me go backwards then. How many of you say less? Anyone else say less? How about the same? Anyone? All right, it is greater, but why? Yeah, why?
Alright, so when you're pulling on the larger thing, whatever, on the larger mass, then it's going to stretch it, but not as much, because since the other one is lighter, then it's just going to pull it with less
Okay,
force pulling it.
right?
But since the other one, you're applying the same force, even though it's the same force, you're applying it on the smaller of the masses. So, in order to start dragging the larger mass, it's going to take a larger stretch of it.
Okay. All right. Does
I
anybody...
did that all in my head logically, not scientifically.
I know, the thing is that a lot of times you can logically think it out in your brain, but writing it down on paper is a totally different thing. Can somebody give me an explanation in 2 sentences or less?
I see so.
Because I worked it out in the work.
The
Because
mass-
you did the math.
The mass being pulled
Okay,
is
yeah.
heavier.
Yeah, the spring in the second, hold on. The spring is pulling a greater mass, right?
Spring is pulling a greater mass now, that is correct.
Assuming
So-
that friction, the coefficient of friction is the same.
Actually, that's frictionless, I think.
Oh.
So yes, it is.
Yeah.
But since the spring is pulling a larger mass, but at the same acceleration, then you have to have a bigger force, right?
Yeah.
Okay, that'll work. Okay, E, in the new situation, the blocks and the springs are moving together at a constant speed of 0.5 meters per second to the left. Block A then hits and sticks to the wall. Calculate the maximum compression of the spring. Whoa, okay. So did you catch that?
No.
It goes like this. This one hits the wall, and this one compresses the spring. What's the maximum compression? All right, tell me, everybody. What kind of physics do you think?
Maybe.
It looks like a collision, but can somebody tell me why momentum will be a challenging way to work this one? Or we really can't do it with conservation momentum anyway?
Because it runs into a wall.
Because it runs into a wall that's not free to move, right? So we have an outside force that messes up conservation of momentum. However, what else can we use?
Energy
Energy. Can we say we have a certain amount of energy to begin with, and then when it hits the wall and the thing compresses? But energy for what? This one's going to stop. So will the energy of this one be conserved?
No.
Okay, but the kinetic energy of this one is all going to turn into spring potential energy here, right? So that's the key. So that's a pretty hard question, actually. So the kinetic energy of this one is going to turn into spring potential energy of that one. Okay? So 1/2 mv squared is all going to turn into 1/2 kx squared. Halves go away, and you can calculate what the compression is going to be. All right?
Well, wait, velocity? Oh, yes, I see.
Yeah, they gave you the velocity.
And that's, and wait, that, and this is assuming which one's first? A is first.
A is first. Yeah, they gave the spring constant at the very beginning. All right, so x turns out to be 0.16 meters. Okay, we're just about out of time. What questions do you have
The one you get out of my seat, so.
about the test coming up and all of that?
Is it not just forces? Can we solve everything in the equation?
Okay, there are going to be some questions on this exam from previous chapters. Like, for instance,
Is it that,
obviously some of these questions, like this one, have energy in it, right?
is that thermal gonna be in there?
We certainly could have a collision. Some of these will require kinematics, because every time you have forces, F equals ma, sometimes you have to use kinematics to find A. But in an effort to get you to remember all of your physics up to this point, there certainly could be a thermo question.
So does that mean you are gonna put it in there?
The test is
Probably.
The test